Hello everyone and welcome back to ImTechnos. In today's video, we will dive into AWS Elastic Compute Cloud. We will start by explaining what EC2 is and then walk you through a hands-on demonstration. Let's get started. EC2 stands for Elastic Compute Cloud. The term compute refers to the server or the computational resource that powers your application. Cloud signifies these servers are hosted remotely in the cloud, eliminating the need for physical hardware on-site. Elastic highlights the ability to automatically scale the number of servers up or down based on real-time application demand, ensuring optimal performance and cost efficiency. In AWS, we refer these servers as instances. These instances are virtual computing environments, meaning EC2 instances are virtual machines. They support scalable compute capacity with no upfront hardware cost and operate on a pay-as-you-go model. Now that we understand what is EC2 instance is, let's jump into a hands-on demo. First, we will launch an EC2 instance, install a basic web server, and access it via instance public IP address. To get started, ensure you have an active AWS account. You will need EC2 permissions to manage instances and assign IAM role. Additionally, make sure you have an IAM permissions to create roles with Systems Manager access. Start by logging into the AWS Management Console. For this hands-on, we will be working in North Virginia region. In the search bar, type EC2 and select it. This will take you to the EC2 dashboard where we can view all the EC2 resources. If you scroll down, you will find the service health section. The North Virginia region is provided with 6 availability zones, and as of now, all systems are running smoothly with no issues reported. To launch an instance, you can either click on the instances under the resource section or simply select the instances from the left navigation menu. Both methods will take you to the same place, so feel free to choose whatever you prefer. Click Launch Instances to explore the steps involved. The first section is Names and Tags. Tags acts as labels for your AWS resources, such as EC2 instances. For example, if an instance hosts your application, you could name it as a web application. You can also add additional tags, each consisting of a key and a value. Let's say if the instance is a production server, you could tag it with environment as a key and production as a value. If an employee is working on it, you might use employee ID as a key and the employee ID like ID 1234 as a value. Additionally, if the instance belongs to a specific client, you can tag it with the client and assign the client name as a value. This way, you can add up to 50 tags in total. So we have already added 3 tags and we have 47 remaining. Tags are essential for categorizing and organizing your EC2 instances. Imagine managing hundreds of EC2 instances. By assigning tags, you can easily filter instances. For example, if you want to find all the EC2 instances associated with a specific client, simply filter by the client tag. If you need to apply patches specifically to production servers, you can filter by the environment tag. While tags may seem like simple identifiers for your EC2 instances, they are crucial for efficient management, especially when using AWS Systems Manager to automate tasks and maintain your infrastructure. However, for this demo, I will use first instance as a tag value. If you would like to apply the same tags to the volumes created with your EC2 instance, you can enable the volumes under the resource types. Now let's talk about AMI. AMI stands for Amazon Machine Image. Think of an AMI as a blueprint that provides all the software required to configure the operating system, applications, and supporting libraries for your EC2 instance. Essentially, choosing an AMI means selecting an operating system for your EC2 instances. AWS offers a wide range of operating system options, including Amazon Linux, a Linux operating system developed by AWS, Mac OS, Ubuntu, Windows, Red Hat, SUSE, and Debian. To explore all available options, click on Browse More AMIs, where you can filter the AMIs by architecture, OS category, or whether they are eligible for free tier. You can also create your own AMIs, which will appear under My AMIs. Currently, there are no AMIs, but we will create one in future videos. AWS Marketplace is an online store where you can purchase third-party AMIs from trusted vendors like SAP, Cisco, and Zen. The marketplace AMIs are neatly categorized, making it easy to find the right product for your needs. Additionally, you can create your own AMI and sell it on the AWS Marketplace. Note that Marketplace AMIs are chargeable with cost determined by the AMI owner along with the standard AWS service fees. Another option is community AMIs, also known as shared AMIs. These are AMIs created by other users and made available for public use. For instance, if you want Kubernetes installed on your EC2 instance, you can search for Kubernetes in the community AMIs. However, it is essential to know that not all community AMIs are secure. AWS recommends using AMIs from verified providers such as Amazon or its trusted partners, which are labeled as verified provider. If you see quick start AMIs, they're always marked as verified providers. For this demo, I will choose Amazon Linux 2 AMI, which is eligible under the free tier. And then instance type. It defines a hardware configuration for your EC2 instance. It bundles together a combination of CPU, memory, internal storage if applicable, and network performance. However, you don't need to select each component individually. By choosing an instance type, you get a pre-configured package that fits your needs. With over 800 plus instance types available, they are categorized into different instance families for various workloads. If your application need high performance compute for CPU intensive tasks like gaming, high performance computing, and machine learning inference, then go for compute optimized. Memory optimized instances are designed for memory intensive applications such as big data analytics, in-memory databases, and real-time processing. Accelerated computing instance types are equipped with GPUs, graphics processing unit, for workloads like machine learning training, video processing, and scientific simulations. Storage optimized instance types are designed for high read-write performance with local storage and are ideal for NoSQL databases, data warehousing, and analytics. HPC optimized instances are designed for massively parallel workloads that require high compute power, low latency, and fast networking. They are ideal for use cases like weather modeling and computational fluid dynamics. If you are looking for balance of compute, memory, networking for a wide range of workloads like a simple web servers and development environments, then go for general purpose instance type. If you're wondering which instance type is best suited for your application, I recommend thoroughly exploring this page and choose the optimal instance type for your needs. For this demonstration, we will use a T2 micro as an instance type, which falls under the free tier. And then key pair. Key pair is used to log into your EC2 instance. A key pair is a combination of two keys, a public key and a private key. When you launch an EC2 instance, EC2 stores the public key on the instance and you are responsible for storing the private key. It is important to store your private key in a secure place because anyone who has your private key can connect your EC2 instance. Depending on how you manage your security, you can either use the same key pair for multiple instances or assign different key pairs to each instance. While it's possible to launch an EC2 instance without a key pair, you can also choose an existing key pair if you have one. If this is your first time launching an EC2 instance, you will need to create a new key pair. Start by providing a unique name for your key pair, like a key one, and then select the key pair type. There are two common cryptographic algorithms, RSA and ED25519. RSA is widely supported across various operating systems. while ED25519 is not compatible with Windows instances. If you're planning to use the same key pair for both Windows and Linux, RSA is the preferred choice. For private key file format, we can choose either .pem or .ppk. For example, if you launch a Linux EC2 instance, you can use .pem format to connect from any operating system. Your machine can be a Linux or a Windows or a Mac. However, a PPK format is specifically designed for Windows by installing putty. Okay, so if you need flexibility and plan to connect from multiple platforms, it's best to opt for .pem format. So I'll go with .pem. Once you made your selection, click on Create Key Pair. You will be prompted to store the private key on your laptop. I have chosen to store it in a key pair folder. This file contains a private key which you can open to view it. Please remember that it is not advisable to share your private key publicly. I'm sharing it for educational purpose and I will delete it once this session concludes. So with the key pair selected, let's proceed to the network settings. The VPC, which stands for Virtual Private Cloud, is a foundational network service in AWS. It provides a logically isolated environment within the AWS cloud where you can define your own IP address ranges, subnets, routing rules, and more. Essentially, it forms a network layer for your EC2 instances. The one that is selected is the default VPC that AWS creates for you automatically when you first create an AWS account. This pre-configured network simplifies deployment for beginners. If needed, you can design your own VPC with specific settings to achieve greater control and customization over your network. For now, I'll stick to the default VPC. Subnets are the segments of the VPC IP address range and are required for launching EC2 instances. Each instance must be placed within a subnet. In the default VPC, AWS provided a pre-configured subnets, and you can either manually select one or allow AWS to choose one for you by opting no preference. By enabling the auto-assign public IP option, AWS assigns a public IP address to your EC2 instance, making it accessible from the internet. We will delve deeper into AWS VPC in future videos while exploring networking services. A security group is a firewall for your EC2 instance. If this is your EC2 instance, the security group acts as a firewall. Using security groups, you can control who can access your EC2 instance and through which protocol. When setting up security group, you can either create a new security group or choose an existing one. If creating a new security group, you can specify a name, for example, web server security group, and add a description such as allows SSH and HTTP protocols. When you choose a Linux AMI, the one which we have chosen, AWS automatically adds SSH protocol to allow remote connections as SSH is required to log into your Linux instance. Conversely, for a Windows AMI, AWS enables the RDP protocol. So AWS is smart enough to select the right protocol according to the operating system you selected. So SSH is a TCP protocol operating on port 22 requires a source type to define who can access your EC2 instance. So this is the source. So we are allowing SSH access, but for whom is where we define here. Selecting anywhere allows anyone to access your EC2 instance through SSH protocol. Choosing custom lets you specify IP ranges restricting access to specific addresses. Selecting my IP limits access to your machine alone. However, for this demonstration, I will select anywhere, but in real-world scenarios, custom is typically chosen to restrict access to client-specific IP ranges. You can also add descriptions for each individual rules to provide clarity. Security groups allows multiple protocols depending on your needs. For example, SSH for remote connection, HTTP for web servers, MySQL for database access, DNS for domain name resolution, and ICMP for network diagnostics, and so on. For now, I will only enable SSH, but additional rules can be added later if required. For storage, we use EBS volumes, which stands for Elastic Block Store. EBS is a highly durable, high-performance block storage service is designed to be used with EC2. The volume 1 typically refers to the root volume of the EC2 instance. This is the primary storage volume where the operating system and other essential system files are stored. The AMI root refers to the root volume created from the AMI that you have selected to launch your EC2 instance, and it is the default storage location where the operating system will be installed. It also allows us to modify this root volume, adjusting the size, changing the volume type, for example, from GPT to IO1, or configuring additional settings like encryption for enhanced security. EBS indicates the storage type is Elastic Block Store. This is the device name assigned to the root volume within your EC2 instance. It defines a path of the volume within the instance file system. The snapshot here is used to create the root volume. The default size of EBS is 8 GB, which can be adjusted based on requirement for your application. And this size varies depending on the selected AMI, but you can scale the size as needed. The volume type specifies the type of the EBS volume, and in this case, the GP2 is selected, which is a general purpose SSD. I have created a video on EBS volume types to explain the differences in detail, which you can refer to. I'll include the link in the description below. IOP stands for input output per second. It represents the performance characteristics of the volume. A value of 100 is the baseline IOPS for this volume type, and up to 3000 burst IOPS can be achieved depending on usage patterns and available credits. The delete on termination option is set to S, which means the EBS volume will be automatically deleted when the EC2 instance is terminated. You can change this setting to no if you wish to retain the volume for future use. This volume is not encrypted by default. However, you can enable encryption using the AWS Key Management Service KMS, ensuring the data is securely stored, transmitted, and backed up. If you enable encryption, you will need to select a KMS key. This option is applicable if the volume is encrypted. However, I'll keep it as not encrypted. In addition to this root volume, you can also add data volumes. These data volumes have similar options, but by default, the delete on termination is set to no for data volumes. You can choose S or no for both data volumes and root volumes, depending on your preferences. Adding data volumes is optional when launching an instance, but the root volume is mandatory. So for this demo, I'll stick with only root volume. With these options, you can now ready to launch an EC2 instance. However, let's take a moment to explore two additional important options under the advanced details before proceeding with the launch. The first option is the IAM instance profile. An instance profile is essentially an IAM role that grants the EC2 instance a set of permissions. These permissions define which actions the instance can perform within AWS. Let's imagine you have an application running on EC2 instance. And this application need to interact with the database, which in this case is RDS, which stands for Relational Database Service. For those who are new to AWS, RDS is AWS fully managed database service. If the instance need to retrieve or store data in the database, it must be assigned an IAM role that grants the necessary permissions to access and interact with RDS securely. So in conclusion, an IAM instance profile is an IAM role that is assigned to this EC2 instance to provide it with necessary permissions to securely interact with other AWS services such as RDS. The second option is user data. This option allows you to specify a script or a set of commands that will run automatically when the EC2 instance is first launched. User data is typically used for automating the configuration of an EC2 instance. This script can perform tasks such as installing software, configuring settings, or setting up system environments. Please note that user data scripts are executed only during the first boot of the instance. User data can be a shell script for Linux instances or a PowerShell script for Windows instances. These scripts can include commands that configure the instance, install packages, or set environment variables. Be mindful when you are using sensitive information such as passwords or API keys in the user data script because it will be visible in plain text. To manage sensitive data securely, it is recommended to use EC2 instance metadata or AWS Systems Manager parameter store. In the summary, it provides an overview of the configuration settings you have selected for your instance. It acts as a final review of the options you have chosen before proceeding with the launch. Once you have confirmed everything is correct, click on Launch Instance and wait for the instance to initialize. Now that the EC2 instance is successfully launched, the next step is to connect to the instance, install a web server, access using the public IP address. It's like having an application and accessing it through a browser. For example, imagine this instance is hosting a Facebook application. To access it, we type facebook.com in a browser, right? But does the EC2 instance have domain name by default? No, it doesn't. Instead, a user-friendly domain name like facebook.com or gmail.com is created and mapped to the public IP address of the application instance. When you enter facebook.com in the browser, the domain name resolves into the public IP address, the request reaches the server, and the server returns the appropriate login page. However, this is not a Facebook application and we don't have a domain name. So what we will do, we will directly host this web server using the public IP address from the browser so that we get the default web server page. Now that you know all the steps to launch an EC2 instance, in part 2, I'll show you multiple ways to connect your EC2 instance, including SSH, Session Manager, and more. So stay tuned for part 2.